So this lecture is all about simple linear regression, which if you have noticed, it will be like the bivariate stuff that we have been going over for the past 3 weeks or 2 weeks. I don't remember. I don't know. Anyway, so this is taking one independent variable and the influence or effect on one dependent variable. So we have explanatory and dependent variables, just like in the modeling handout where we had exogamous and endogamous. So we have x, which is the independent variable, as having the influence on y, or y equals the function of x. So what we can do with regression is that we can take multiple independent variables and put them all in the same model. So that's the benefit of doing a regression, of being able to do a regression, so you can have more than one independent variable. So previous weeks, 3 weeks, we've been chi-squared, where we had one nominal independent variable, and we're determining the influence on one nominal dependent variable. And in t-test, we had one interval ratio variable, and then the influence on one interval ratio dependent variable. And in ANOVA, we had one independent variable with multiple categories, how it's influence on the dependent variable. So it's one independent, one dependent. And a multiple regression is the idea is that you can have multiple independent variables in the same equation. So questions that we can address in regression: is there any relationship or association between x and y? If so, how strong is that association? Is it positive or negative? What is the precise nature of the relationship between x and y, and how exactly will y change when x changes by a specified amount? How much of the change variation in y is explained by the specified change in x? So basically what we do in a regression is that we take all these data points and we graph them, and we try to draw the best line that we can through those data points. And then the deviations are the points, how far away are the points from the line that we drew, and we want to make that length between the point and the line as small as possible. So we define a line as y equals a plus bx, where a is the constant and b is the slope of the line. And I think in your stats class you do it y equals mx plus b, where m is the slope of the line and b is the constant. The constant, in other words, is where the line crosses the y-axis and the x equals 0. So in my terminology, b is also known as the regression coefficient, enables us to predict how y will change when x changes. So now we're going to do some examples where we're doing just one independent variable and seeing how it affects the dependent variable. So if you have a positive slope and it's upward, so x rises, there is a rise in y. And then when x falls, there is a fall in y. And if you have a negative slope, then it's downward direction of the slope of the line. And then when x rises, there's a fall in y. And when x falls, there is a rise in y. So they're like opposite in the last part. So we need this following criterion to adopt the best fit line. So we find a line with the best fit, and we do this by regression lines predicts the values of y that will be given by the corresponding values of x, and we look at the residuals, so deviations, the actual y's from the predicted value. So vertical distance from the line yi minus the hat yi. This again was the example of where we're trying to draw the best line, and we calculate the space between the point that's not on that line and to the line, and we want to make that as small as possible. So residuals are deviations of the actual ys from the predicted value. So the vertical distance from line yi minus y hat I. But if you have a y hat I minus a y hat I, the negatives and positives would cancel each other out. And so we square it to make sure it's not negative or positive, and then we sum the deviations. So best fit line is regression line, has two variables, x and y. The best fitting regression line is defined as the line that minimizes the sum of the squares of the vertical deviations of all the pairs of values of x and y from the regression line. It's called ordinary least squares, or OLS regression. So here's a regression coefficient, which is determining the slope of the regression line. And hopefully you did this in stats class. And if we calculate the regression coefficient for 4 values of x and y, and if you decide to email this to me, I will give you extra credit for calculating the deviations by filling in this table. And then here's how to calculate regression coefficients.